All right, so what we have here is another round of finding exact values. And then the ratios, with the exception of a case, are not nice ratios. So what's also a little bit tougher about these is that I actually have two inverse functions working with each other or working against each other, however you want to kind of put that together. But remember, this right here represents some angle. All right, so that's what we have there with regard to this. So we can probably begin by looking at this side a little closer and saying that theta, right, is the arc cosine of 5 over 13. All right, so this means that the cosine of theta is 5 over 13. All right, and so what we end up getting, right, is that we can start building a right triangle for the situation, or XYR definitions, whatever you want to do with regard to this. I'll go ahead and do a right triangle. The right triangle in this case is going to be in quad 1, right, because we're nice and positive, and this is x over r, so we have 13 and we have 5, so all we have to do is find our y value. And of course that invokes our Pythagorean theorem. So 5 squared plus y squared is 13 squared. I believe this will be 169 minus 25. Y squared is 12. All right, and so y is plus or minus, 144. I was getting to say it's plus or minus 12. And since we are in quad 1, we're considering the positive route. All right, so we've got basically this is 12, this is 13, this is 5, and there's our angle theta there. All right, so that work now prepares us to come back over here. So we're looking basically at the arc tangent of x is equal to this theta that we drew. Well, rewriting this is basically saying that our x is the tangent of that theta. So now I need this right triangle, right? Because this is basically my opposite over my adjacent. And for this case, right, for this theta, the opposite is 12 and the adjacent is 5. So in this case, x, right, arc tangent of 12 over 5 is equivalent to the arc cosine of 5 over 13 based off of this triangle that we drew. So there's your idea. So I have two of them. What we'll do is we have enough information to do the data, pictures, XYRs, whatever you want for one of the sides. And then once we get that, we just rewrite it and do things in terms of the other one. So it's kind of like we start off with two inverses, but we're breaking them down. So one of them we can analyze, and then we can use that analysis to find the other one. So here we have the arc sine of x is equal to the cotangent of -1 of 4/3. Well, again, this is equal to some theta, right? So theta is equal to the inverse cotangent of 4/3. What this means is that the cotangent is equal to 4/3. So again, drawing another right triangle. Because we're positive, again, we are sitting in quad number 1. Cotangent is defined to be the adjacent over the opposite. So this is basically saying that my adjacent side is 4, my opposite is 3, so we basically have to find r. So invoking the Pythagorean theorem, 4 squared plus 3 squared is r squared. In this case, r squared is 25. Taking a square root, r is 5. It's always positive. So this is 5. There's our angle theta, right? This is 3 and this is 4. So coming back over here, we have the sine inverse of x is equal to this theta that we have analyzed over here. So this means my x is the sine of theta for this situation. Sine of theta for this situation is always the opposite over the hypotenuse. And in this case, my opposite is 3, my hypotenuse is 5, so we get 3/5. So in this case, x is equal to 3/5. Okay, changing things up a little bit. Here we don't have the inverses equal to each other, right? What I actually have is I've got an inverse that are on the same side. So we're taking an inverse trig function adding another inverse trig function, and it's equal to some value 2 pi over 3. So what we first have to do again, since we got this value here, let's consider theta is equal to the inverse tangent of the square root of 3. Well, this is basically telling us that the tangent of theta is equal to the square root of 3. And I believe in these conditions, right, what we have, again, in terms of a right triangle, we have the square root of 3, right, we have 1, and we have 2. And there's our theta. So for this relationship, right, opposite over adjacent would be square root of 3 over 1, and that's basically theta equals to 60 degrees, which we know to be pi over 3. So bringing that back over here, we're basically looking at the sine inverse of x is equal to, or excuse me, sine inverse of x plus pi over 3 is equal to 2 pi over 3. So if we subtract pi over 3 from both sides, we're now looking at the sine inverse of x is equal to basically pi over 3, right? 2 pi minus pi is 1 pi. And so x is the sine of pi over 3, right? And again, if you want to just look at this, or if you want to go to your unit circle, right, it's this is defined to be the opposite over the hypotenuse. My opposite is the square root of 3. My hypotenuse is 2. So for this particular situation, x is equal to the square root of 3 over 2. All right, so a little bit tougher to do, but we're still, right, just using what I have. There's enough information to analyze an angle. And then once I have that angle, I plug it in, and then just, maybe it's an easy conversion, and then just reading our information, or perhaps there's a little bit more work. In this case, we had to subtract and go from there. But there's basically your flow. There should be enough information to analyze the angle that we have, and then from that analysis, we should be able to take care of the other remaining inverse trig functions. So classic cases. In 6.4, there are much tougher ones, but if you find something that looks a little bit almost too tough, let me know, because I know we're getting towards the end. I'm trying to, what's the famous word, to kiss it? Keep it simple, stupid. All right, so I'm trying to keep it simple, stupid. All right, so hopefully I'm not stupid and giving you anything too hard. These are already hard enough, right? So we're kind of piecing together things together. There should always be enough information. Let me give you an idea what makes this tougher. Like, for example, here, notice that there was enough information always to find and analyze one of my angles. What makes these things extremely tough is if I have something like the sine inverse of 2x plus the tangent inverse of x, and that's equal to, like, let's say 0. This is tougher because there's, I have to draw a picture for this one and draw another picture for that one, and that's pretty tough, right? Because there's basically two different unknowns, there's two different angle arguments, very, very important, very, very difficult problems. But like I said, I'm just trying to keep it simple. One of your angles should always be able to be analyzed using right triangles, XYR definitions, or your unit circle, and then it's just basically plugging that in, converting things over, and eliminating the other one. I'm trying to keep it that simple and get you guys just used to working with inverses and moving back and forth. That's essentially the goal. All right, so that wraps up 6.4. Again, if you have questions, please ask them. Please continue to keep showing your work. It gives me an opportunity on Canvas to correct you and get you ready for those quizzes. Finish strong, you guys. We're almost done.